So I have started the recording. Welcome everyone to SQL Friday. This is number 19 with Gianluca Sartori, who's going to tell us all about benchmarking in the cloud. And well, the content you will tell about it. I'm not going to spend too much time on it. I'm really glad to have you here, Gianluca. I've seen your presentations a couple of times. Last time I think was on Data Weekender. You did a presentation about monitoring without breaking the bank. So it seems like monitoring is your big thing. Welcome to SQL Friday. The stage is all yours.
Great. Thank you very much for having me. It's a pleasure and an honor. So I suppose I can start sharing my screen. So let's try that. Drum roll, and it should be online.
It is. I said that twice, but I didn't have the mic on. So
great. Okay, so welcome everybody. The topic for today is benchmarking in the cloud. A few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant, and I've been doing this for a very long time. It's been 20 years, which also means I'm pretty old, which is a bit unfortunate, but that's life. And currently I'm working as a DBA at a famous Formula One team in Italy. If you want to read my blog, you can find it at spaghettidba.com. And my handle on Twitter is @spaghettidba. So let's go with the agenda for today. First of all, we are going to get through different scenarios. So why we would want to take benchmarks, why we need benchmarking. And then we will go through some tools and the challenges involved in using those tools, because we will see that it's, not an impossible deal, but it's a bit complicated. It's a bit hard to get right. So then we will move to the cloud, and we will see that things get even more complicated because we have less tools and more challenges, and we will try to overcome those challenges. And then we will introduce workload tools, which hopefully is the way to overcome those challenges. Great, so let's go. First of all, definitions. What's a benchmark? It's the main topic for the presentation, so we'd better get this right. This is something that describes the performance of your system in a given scenario. So if I go to my server and I take a snapshot of what performance looks like, that's a benchmark. And that is obviously helpful to know how my server is behaving right now, but it is also interesting in order to understand what would happen if I changed something. And that could be anything. It could be something that has to do with your hardware. So you want to for instance, upgrade your storage. You want to buy that very expensive storage, and you want to know what would happen if that is really worth all the money you're throwing at it. And the way to do that is to have a benchmark, compare it to what you have now, and see if things are better or worse. It's also useful for software upgrades, and that could be anything in your software stack. SQL Server, of course, but also other pieces of your software stack, like the application server or some libraries in your software. And also has to do with scenarios like virtualizing your physical servers, if you still have any, or maybe consolidating your servers to a single virtual environment, or migrating your servers to a different data center or to the cloud. It also is a good way to understand what would happen to your environment if you changed something in trying to improve performance. So you do some changes at the server level, like enabling trace flags, or changing configuration options at the server or database level, and you want to understand whether that has a positive or negative impact on performance. Or maybe you change something in the database itself, like adding more indexes or changing something in your code, stored procedures and stuff like that. And if you take a benchmark in the new situation with your tuning measures applied, you can compare that to what you have without your tuning measures. And that is interesting to understand what is the global impact of those changes in your workload. For instance, when you add an index, one or two queries could be faster, but maybe inserts or updates are slower. And the only way to get that is by comparing a benchmark against a benchmark that has been captured against your whole workload. So what do we have inside a benchmark? Obviously, as we said, we have performance data, and that has to do with some performance indicators like performance counters. So we have things like number of batches per second or CPU consumption. So performance numbers that have to do with resource consumption strictly. And then we have other things like weight stats. But besides this, we also have a very important part that needs to go inside the benchmark, which is the workload that determined the performance numbers that we got. So this is all your queries, and all these queries will have some performance numbers tied to them, like the duration, so how long it took to run the query, the CPU it used, the number of reads and writes. And all these performance indicators are not relative to the server as a whole, but specifically to that query in that specific point in time. So this is good to go and see exactly how a query was behaving at a particular point in time and see which performance numbers it produced. So the overall process for running benchmark, capturing benchmarks and replaying them against the test environment looks like this. You probably want to have your production environment as the source, and then you have something, a tool that captures your benchmarks in production. And what you have inside, as we said, is some performance data and the workload. So all the queries that have been captured at this stage. And then you have a test environment, which is the one that you want to assess, the one you want to compare against production. And here you have all your changes. So the new storage, the new changes that you made to the database, all the things that are different compared to your production environment. And at this stage, you have another tool that replays your workload, so all the queries that you have inside here, and replays them against this test environment. And at the same time, while the replay is running, we have a second instance of the capture tool that takes another benchmark that contains, again, performance data and all the queries with their performance numbers. And then you can go and compare the two. And the things you want to catch at this stage are things like regressions, so queries that were running fine in the source environment and are not performing as well in the target environment. Or other things you want to capture here is things that stop working altogether. So imagine that you want to move from an older version of SQL Server like 2014 to 2019, and some things have changed from your source version to your target version, and some features have been deprecated for a long time, and when Microsoft pulls a trigger, those features go away completely, so they stop working, and you want to catch that here before you hit production. Other things you want to catch here is how good your tuning efforts are performing. So you want to see whether they have a positive or negative impact overall on the whole workload, not just on the 2-3 queries that you identified. Cool. So it looks pretty simple, but it is in fact a bit complicated. If you try to do this, you probably know this is not exactly easy to do. And most of the pain comes from choosing the right tool for the job. We have many here. We have tools for capturing the source workload. We have tools for replaying the workload and others to compare the results. But we need to be careful and know the limitations of each of these tools. So let's try and describe them and see what they have to offer and where they fall short. So first of all, as we said, we need to capture the queries, and immediately Profiler comes to mind. It's the most renowned tool for capturing queries, and it's been around for a very long time. The first version that had Profiler was version 7, so it's 20 years that Profiler is around. Everybody knows it, but it is good for its simplicity, but it has a non-negligible performance impact on the server. So this means that if you point Profiler to a very busy production server, you will probably end up slowing it down. So that's not exactly what you want to do. And if you want to have a lower performance overhead on the server you are observing, you probably want to turn to extended events. Microsoft designed extended events specifically from the start to have a low performance overhead compared to SQL Trace and Profiler. But again, it's not all happiness and unicorns, even with extended events, because it is not compatible with all versions of SQL Server. It has been introduced in 2008, but in the beginning, it didn't have all the events and the columns that you had in SQL Trace available. So we had to wait for SQL 2012 before it had feature parity with SQL Trace. So if you're working with an older version of SQL Server, I know that 2008 is deprecated, is not supported anymore, but if you go to your customers, they probably still have it in production. Some of them still have 2005 or 2000. So yeah, real life, it is what it is. And if you're working with an older version, you probably still want to stick with SQL Trace. It is a bit old school, it is deprecated, but it still works with a wide variety of analysis and replay tools that have been around for a long time. If you also want to capture Windows performance counters, you have tools for this. So when it comes down to performance counters, we have two kinds of counters. Those that are specific for SQL Server and those that are related to Windows. And those in general have to do more with resource consumption, like CPU counters or disk counters. Those for SQL Server are more specific to things that have to do with the database itself, like page life expectancy or number of batches per second and so on. And if you really wanted to have a list of meaningful performance counters, that would take a session on its own. Oh, we have a question, I see. I see a raised hand.
Aaron, if you have a question, please type it in the chat, and I can relay it later on.
Okay, so as I was saying, if we wanted to get a list of meaningful performance counters, that would be a huge list. And there's no way I can tell you in 60 minutes only that. But the good news is that you don't have to know that list by heart. All you have to do is download PAL, which is a nice little tool from a Microsoft employee. It's an open source tool. You can find it on GitHub. And it contains meaningful performance counters and thresholds for a wide variety of Microsoft applications, including SQL Server. So if you download it, there's an XML files that contains all the performance counters that are meaningful for SQL Server. And once you have all your data captured, you also have to analyze it. And in order to analyze it, there's again some tools to do that. Probably the most renowned ones are the RML utilities. This is a set of command line utilities from Microsoft. And they contain tools for capturing and analyzing and replaying workloads using SQL trace. There's a utility in there that is called readTrace. So as the name suggests, it reads a trace and writes all the performance information related to the queries inside the trace inside SQL Server database, and then you can run a tool called Reporter that displays the information in that SQL Server database. There's another tool that you can use for this, which is called SQL Nexus, and it goes on top of some components of RML utilities. Another interesting tool is called ClearTrace, and this is not from Microsoft. This is from Clear Consulting or something like that. It's from Bill Graziano. And what this tool does, it goes through a trace and takes all the queries and normalizes them, which means it takes away all the constants and the literals inside the queries and replaces them with placeholders. So that you can take queries that differ only by the values of the constants and group them together and analyze them together. So this is pretty cool. And another tool for this, as we said, we have PAL for analyzing performance counters. This is basically a PowerShell script, and it goes through all the counters and writes as an output, creates some reports in HTML that you can go and analyze. There is also another interesting tool from Microsoft, which is called DEA, Database Experimentation Assistant. And what this does is it's a complete A/B testing solution. So it takes care of capturing, replaying, and analyzing workloads, and it uses distributed replay and some charts in R. So this is pretty cool as well. I had a bit of a hard time using it at the beginning, but I was told it has improved a lot since the early days. When we need to replay the workload that we captured, well, again, as an option, we still have Profiler, but this is not suitable for replaying a long capture of a huge workload. This has a UI. So what you can do is stop the replay, pause it for a while, set breakpoints. So this is good for debugging or troubleshooting rather than replaying a workload. And then we have RML utilities that again have some tools for this. There's OStress, which is a tool capable of taking the output from read trace and run it against a target environment. It has two ways of working. There's the stress mode and replay mode. Stress mode takes all the queries and runs them one after the other, so there's no pause between the queries. In replay mode instead, it tries to mimic the source workload, so it tries to respect the pauses and the source workload. So if you have a user going around on a web page, clicking on links that do actions on the backend, there's some weights between user actions, and those are meaningful for mimicking the replay in the target environment. And what replay mode does is exactly this. So it tries to mimic the source workload as closely as possible. In SQL Server 2012, we also had the introduction of distributed replay, which can do all the things that OStress does, but it also has the ability to replay a workload using multiple nodes. So you can use multiple machines to replay your workload, and this has an impact, especially when you're trying to replay a huge workload that you want to have it as parallel as possible with many clients trying to run queries. It also supports what RML utilities has with replay mode, so respects the weights in the source workload, but this time it's called synchronization mode because Microsoft likes to change names to things. And okay, so when you use traditional benchmarking tools, what you do is you have your production database, you capture a trace or a set of XEL files, so extended events files, and then you process them afterwards. So after you stopped capturing. And then what you have is an analysis database that contains all the data that you processed by reading these files and a set of stub files that you can use to run the replay against the test database. And again, while the replay is running, you can capture again trace files or XEL files, and then you process them again and write to the same analysis database so you can go and run reports on top to see the difference between the two workloads. And this is a bit problematic for some aspects. For instance, while you are capturing your workload, if you do that on a very busy server for a very sustained time, what you can end up is a set of huge trace files that can fill your disk on your servers, which obviously you don't want to happen. And also, while you're processing your files, these tools like ostress and distributed replay can end up crashing and fail to process the files, which is a bit inconvenient when you have been capturing these files for hours or days. The same can happen during the replay. So again, you're capturing, so you can end up filling your disk or having a set of files that you cannot process. So in order to overcome these limitations, we will see later what we can do with WorkLoadTools. And also, if we move to the cloud, things get even more complicated. We also need to understand what we mean by cloud, because we could have very different situations depending on what we're doing. So if we have on-premises or private cloud, we take care of everything. So we still have control over all the layers, and we can use all the tools that we described so far. If we go to infrastructure as a service, we still have a VM running somewhere, and we still have control over the operating system. We can go ahead and install the tools and use them without any issues. Things start to get complicated when we go to platform as a service, because we only have control over the data and the applications. So we cannot control the operating system. And well, obviously with software as a service, you don't even need a DBA there. So if we have infrastructure as a service, as we said, it's the same as on premises. You download your tools, you install them, you have control over your disks, and you can do all the stuff you do on premises. With platform as a service in Azure, what you have is two options: managed instance or Azure SQL database. With managed instances, traces are not supported. So a lot of tools that we have seen so far are not available. The only thing that we can use for capturing events is extended events. And we cannot save them to a disk because we don't have disks in managed instances. So the only option is to store those extended events files to a blob storage file target. Or we can stream extended events using the streaming API. Obviously, performance counters are not available for you to capture, not directly at least. The performance counters that you can use are those available through DMVs, which is not the full set. The other option is SQL database, which is even more restrictive. Again, no support for traces. You can use extended events, but this time the only option is to write them to a blob storage, because event streaming relies on an API which is only available when you have sysadmin permissions on the server, which is not the case with SQL database. And again, no support for performance monitor. Okay, so things start to get a bit complicated here. So this is why I created WorkLoadTools. WorkLoadTools is a set of open source command line tools that you can use for all the aspects of benchmarking. So for capturing the workload, for analyzing the workload, and for replaying it. It has some unique features like the ability to run against Azure SQL database and Azure managed instances, and also can do a real-time capture and replay, which is something that I will show you shortly. So it works on two main concepts: the listener and the consumer. The listener is what defines the way you capture your events. So we said we need to capture some queries, and the two ways of doing that is by using SQL trace or extended events behind the covers. And the third option is to take a saved workload that you had previously captured to a file and use it as the source for a replay or for an analysis. And then we can have consumers that take care of doing stuff with the events that you had coming from the listener. So things you can do, we have a file writer consumer that is capable of saving a workload to a file. And what else? We have analysis consumer, and these are those that can take your events and analyze them. So the analysis consumer writes your workload information to a SQL Server database, so you can go later with the comparison tools and analyze the workload. And also you have a replay consumer that, as the name suggests, is capable of replaying the commands against the target database. And the way you use these listeners and consumers is by configuring SQL Workload, which is one of the tools in the tool set, to perform the different actions by using a JSON configuration file. If you don't like JSON files, what you can do is script the whole thing via PowerShell, because WorkLoadTools is also a library. So you can go and load it and instantiate the objects in this domain to use in your own scripts and applications. And the results are easy to visualize because you have a built-in workload viewer, which is a C# application. But you can also use Power BI to visualize the results of the workload analysis. So I suppose you want to see it in action. So let's go and try it. So first of all, we are going to capture a workload and analyze it. So with this first demo, we are going to analyze a single workload in order to find things like the most expensive queries. So we want to see queries ranked by CPU, reads, writes, and this kind of stuff. And what we will use behind the covers to capture the events, it doesn't matter. We just need to configure it. WorkloadTools knows how to start a trace, how to start an extended event session in order to capture the events. We don't even have to specify which events we want to capture. It takes care of everything automatically. Also, to visualize the data, we will have a tool for that. So as you will see, this will be pretty easy. So first of all, we are going to use some demos for this. And as we said, we will try to analyze a workload, and this workload will run against the SQL Server databases that we have on this virtual machine. So we have two versions of SQL Server here, 2016 and 2019, running on this server. And we have this DS3 database on 2019, and we have the same DS3 database on 2016. DS3 is a database used by DVD Store, which is a synthetic workload generated by Dell. Basically, it tries to mimic an online DVD store. So it shows a bit its age. It should be something about online streaming nowadays, but this is what we got. It still works. So first of all, let's close a couple of examples. We are going to analyze this workload, and we will need to start it first of all. So this command, driver light, is what starts the synthetic workload. So let's start it, and we are going to start buying DVDs like crazy in the background. And okay, we said we want to use WorkloadTools to analyze this workload. What do we need? We will need to run SQL Workload, which is one of the tools in the tool set. So you download it, you install it, it goes to your program files folder, WorkloadTools, and you have SQL Workload.exe. And you will need to specify a JSON file with the configuration, so it accepts --file argument, which is the path to the configuration file. So we have this analyze JSON. Let's have a look at the configuration file. So every configuration file needs to have a controller section, and inside you will have the list of listener and consumers. You can have one listener and as many consumers as you want. As you can see, this is a list. So let's have a look at the listener. First of all, you have to specify which one you want to use. And if you go to GitHub in the wiki section, you have all the documentation, and it shows you that you have 3 types of listeners. Extended events workload listener is the one for using extended events. You also have a SQL trace workload listener and a file workload listener. In this case, we are going to use extended events, and we need to specify which server to attach to. So SQL 2016, eventually in case even the database name. And if you want to work on a single database or a single host or a single application, you can specify filters here for the listener. So in this case, it will use a database filter DS3. Then we have the list of the consumers. In this case, we will use an analysis consumer that will receive all the queries captured by the listener and will analyze and normalize them, and will write them to SQL 2019 to the database SQL Workload 01 in the schema capture. Here we are configuring how often the analysis will write to the analysis database, and this will also be the width in seconds of the intervals that will be used to summarize all the performance data inside the database. So let's go ahead and run this. So good. So it says I am reading extended events data from this session, and it is waiting for events. Let's zoom out a bit, and it will capture events and summarize them to the database every 1 minute. Let's see what we have inside here. So let's go to SQL Workload 01. We have a set of tables here. Capture is a schema, and then we have application databases, and the main one is this performance counter, not performance counters, but workload details. And this contains all the data in intervals, and it contains a SQL hash, which is the hash of the commands, and then some performance numbers. So obviously, we would need to capture this for a very long time in order to have some meaningful information. Or as you can see, it captured some data. So it says I captured 3,000 events, and I aggregated them in 22 rows. So it normalized the queries and saved them to 22 rows, and also captured performance counters and weight stats. So all of that goes to the analysis database. Obviously, we don't have the time to run this for half an hour or 3 hours, but we can go and have a look at what this looks like if you leave it running for a meaningful amount of time. We will go and run this report, and this report runs, here we have it, report.cmd. It runs workload viewer, which is the built-in viewer. You just need to point it to the database, the server, the database, and the schema, and it knows what to do then. So let's run it. And it shows what the workload looks like. So you have the CPU over time. This. Hello.
Hello, Gianluca.
Sorry,
I'm so glad to have you back.
Had a blue screen.
No, you did.
Yeah, I had to reboot my machine. It completely crashed.
Oh,
sorry. So let's try to resume from where we stopped. So as I was saying, you can see here. No, you cannot see.
You're not sharing
right
now.
I'm not sharing. Okay, so you have here CPU, and this is the offset from the beginning of the capture in minutes. So you have CPU and duration and the number of batches per second. And what is interesting is you also have your queries tab here that you can click, and it should open. Come on. Okay, and it shows you your queries hashed and normalized and ranked by duration or total CPU or total reads or number of executions. So which one is the one that is using the most CPU? Let's go here and try to find out. Oh, this is the one. So you can go here and click it, and you see that you have this stored procedure, which is the bad guy. You can also go to the query details, and you can see how this behaves over time. So this is again the offset from the beginning. All the information that I'm showing you is also available in Power BI, but I'm not going to show you the dashboard. It shows exactly the same things. Okay, so let's try to solve the second problem with WorkLoadTools, but I don't have my slides anymore. I need to reopen them again. Sorry, guys, for the trouble. Let's go.
I'm impressed that you just kicked it off from where you left it. So no worries, Gianluca.
Okay. So this time we are going to capture a workload for replay. We need to save it to a file, so then we can replay it at a later time. And we could have used trace or extended events as a format, but I decided against it, and I used SQLite as the storage for my events, for my workload in this case. So let's try and do that. I still have my queries running, so I can stop this. And I can go to the second example. So this time I am going to run this capture CMD, which runs in turn SQL workload -- file. So again, we have this captured JSON. Let's have a look at the JSON file. Again, it contains a listener. It uses again an extended events workload listener. We're still using SQL 2016 filtered by database. This time I'm using two consumers. The first one is the same that we had in the previous example. So it is still running the analysis and writing it to this 2019 database SQL Workload 02. But it also uses a workload file writer consumer, which only needs to know where to write the file. And this is the path I'm using. So SQL workload.SQLite. Let's try to do that. So I'm going to go here, capture, and I'm gonna run this capture. We also need to have, no, sorry, click the wrong one. I also need to start the workload, which is again the synthetic workload. So the SQL, the DS3 database, the DVD store. So once this starts, you should see messages like, I am writing to this SQLite file, but obviously, again, as you see, we have 1,000 events saved and so on. So it is both saving to the file and analyzing the workload. Again, we would need this to run for a meaningful amount of time in order to have something to show you. But again, if I close this, I can show you some examples from previous executions. So what we have here, we have a SQLite file. And if I went here and open it with SQLite viewer, let's see if I have it here. SQLite, no, DB browser. Okay, I don't have it installed on this machine, but there's an open source viewer for SQLite files, and it's a database, so it contains a single table with all the events captured. So then you can go and use that file as a source for a workload, which is what we will do in the next demo. We will use the SQLite file, and I will run all the queries against the SQL 2019 instance. We have some things to take into account when we run replays. We need to take the events and run them against a database that is an exact copy of what you had when you captured the events initially. So you would need to take a backup before you start or at the same time as you start capturing the queries. So you can use that backup to restore it in your target environment and use it as a way to make sure that the commands are running against the same situation in the data. And also other things to take into account. The queries not only run on the server in order to produce the results, they also need to transfer the result sets against the network. And if you are planning to move your workload from your local data center to Azure or any other remote data center, latency and bandwidth need to be taken into account, especially if the application is planning to remain in your existing data center. Also, latency is very, very important for that, so it needs to be taken into account. Okay, so let's try to do that. No, not what I wanted to click on. Where is my, okay. There it is. It is a bit slow, this server. So we're going to this example. We are running the replay. So we will have, as we said, we need 2 instances of SQL workload running. The first one will take care of the replay. So it will have a replay.json for the configuration. Let's have a look at what it has inside. So the listener this time is a file workload listener. It is pointing to this SQLite file, and it uses synchronization mode. So replays the queries respecting the source weights. We have consumers here. So I have a replay consumer, and all it needs to know is where to replay the events. I will use an Azure SQL database for this. So all it needs to know is where the server is, name of the database, username and password, in case you are not using Windows authentication, which is the case with Azure SQL database. I am also analyzing my queries. Again, that's one of the possibilities. I did this already when I captured, but I could do this again. So if you decide only to capture initially and not analyze, you can do the analysis at this stage. We will also need to have a second copy of SQL Workload running that captures all the events from Azure SQL Database and analyzes them so that we can go and compare them. So this will be the analyze.cmd, and it will use analyze.json as a source. So let's have a look. We have a listener again. It's an extended events workload listener, and it connects to Azure SQL Database, and it needs to know where to read the files. This time we are not using the streaming API because it doesn't work with Azure SQL Database. So I pointed this to a blob storage where I configured my events to go, and I can use it as a source for extended events workload listener. Consumers, this time I could be writing this again to a workload file. I don't need to do that, but that's again one of the possibilities. And consumers, the one I'm interested in is the analysis consumer that will analyze the events from the target and write them to SQL Workload 03 database. Schema replay, so we will have two different schemas for the source and the target. Okay, enough talking, let's try to do that. Obviously, I can start them at the same time, so I will have two windows. Let's see what it is doing. So now it is replaying. The one on the left is replaying. Really, is it? Okay, see, it's the replay one, and the one on the right is doing the analysis. So they're both running, but again, I would need to run this for a long time before I have some data to show you. So let's pretend this worked for hours. Let's say, okay, I'm replaying, I'm at 2%, but we cannot wait for the remaining 98%. So what I can show you is what it looks like when it runs for a while. And it looks like this. Instead of having one series, you have two series this time. And these two series will be one for the baseline and one for the benchmark. So the source and the target. Baseline is the source and benchmark is the replay. And as you can see, I have a bit more CPU consumption on the baseline, and it's a bit quicker on the CPU on Azure. But looking at the duration is a bit higher on Azure, and that means that the latency does have an impact in this case. If I go to the queries, this time I will have more columns, and I can see the difference between the two. So I have duration, and the difference between the two. So I can go here, rank by this, and see the regressions. Which one is quicker? Oh, this one is quicker. So this has been a regression. And if I go here, I can see the query details. So it shows how it goes over time. So time is running. So I will go to the last example, which is real-time replay. This is interesting for when you have a big workload and you want to capture it over an extended period of time. You don't want to capture that to a file for, let's say, 1 month and try to replay the whole month. So the real-time replay is interesting when you want to capture the whole business cycle and it lasts a lot of time. And if you try to save a workload like this to a file, it would explode. It would be huge. So the strategy here is to, instead of waiting for the events, waiting for the capture to finish, you replay events right away. So let's try to show you that as well. This is a last real-time replay. Again, we need two instances of SQL Workload, one for the replay, so we can see the JSON for that, it uses extended events to capture the events, and this time it replays immediately. So it has a replay consumer, and it writes to Azure's SQL database, and also analyzes, so also writes to the analysis database. And the analysis JSON uses extended events again, and we have one consumer that writes to the analysis database different schema. I don't have time to show you how this works, but I can show you how this looks when you leave it running for, here we go, 7 hours. And it's a long replay. If you try to do this with the other tools, you probably know that even a couple of minutes on a busy server mean capturing gigs of trace files, and that's not always feasible. So if you leave it running for 7 hours, as I did here, this was a client of mine who wanted to migrate from SQL 2008 to 2017. And as you can see, you can see the difference here between the two workloads. So I have a spike here, so I can go and zoom in and see what it looks like when I go here, and I can see, oh, I have a difference in there, so I can have a look at the queries. They're still ranked by difference in duration, so I can go and start tuning from this. And also I can see the query details, so how it behaves over time, and broken down by application, database, host, and login. So I'm sorry it's a bit rushed, sorry for the inconvenience. So just keep in mind that benchmarking used to be hard, but now with WorkLoadTools, it's super easy. And resources for you, if you download the slides, you can find them on GitHub, on my GitHub. So SpaghettiDBA on GitHub, you can find the slides, you can download them, and you have links in there. And if you have questions, please go ahead.
I have one. There is no questions in the chat. I'm super impressed by this last live replay thing. How much pressure does it put? It's just a matter of doing an extended event session on the production machine, right?
Yes, much of the load goes on the machine that is actually performing the aggregation and analysis. So you probably want to run the tools from a third machine, which is neither the source nor the target for the replay.
But it's a super cool thing to have in place. I mean, my current client, they're running lots and tons of batches in the nighttime, and if we would try to rerun that on a production workload, it would I mean, it would take some time, but now we could replay it as we do it on production to see if our tweaks are doing any good. That's pretty cool. I like a lot.
Good.
Is there how to on your website? Is a question from Jens Herman.
Okay, so you can go on GitHub and github.com/SpaghettiDBA, and you have WorkLoadTools. This is the home of the project, and you also have the wiki here, and it contains all the documentation for the tools. SQL Workload is the one that needs to have the configuration file, so you have samples and the links, and all is documented. So go ahead, have a look here. And also on SpaghettiDBA.com, you have some, there's WorkLoadTools category, and you can filter those, and you see some blog posts on how to use the tools.
Cool. Luis is asking, on-prem installation, can we use with ring files on extended events?
With ring files?
I guess it's the ring buffer of an extended event. I don't know.
Oh, okay. You don't need to use targets for the extended event sessions. You define, well, the tool takes care of configuring everything for you, so you don't even have to start the event session. But the session it uses doesn't have any targets. It uses the streaming API to capture all the events.
Yeah, you get a great, amazing back for that answer. And
Good.
yeah, I was impressed by two things. The first is that you were back online and just continue the presentation where you were, not a sweat. So thank you for that. That was really impressive, and I really like the live replay thing. So
Cool.
This is definitely a go-to for me.
Cool, thank you.
For some scenarios I already have in mind for it. So thanks a lot. I'm gonna go to other meetings, so I'll have to rush out of here. But thank you so much for coming. I really enjoyed the session. So.
Thank you for having me. It was a pleasure.
I see in the chat everyone thinks the same. Thanks, fantastic tool. Thank you for sharing. And yeah,
good.
Really good. Thank you so much. I'm going to stop the
Fox.
recording. It's going to come online probably later in the evening. So I'll ping you on Twitter when it's online.
Good. And if you have questions, don't be shy. Just go ahead and shoot me an email.
Yeah. And I know I don't know if you're an addict, but you're on Twitter quite a lot. So I guess
good. That's
it's possible to ask you there as well. So.
Absolutely.
Although email probably has it's easier
more
to get a more detailed answer.
Yes. Good.
Anyway, thank you so much.
Thank you.
I am going to find out how to stop the recording. There we go.
Good.
And